Here's something that might surprise you. Modern passenger aircraft have more backup systems than a NASA space shuttle. And today we're exploring how these incredible machines gracefully handle failures while keeping millions of passengers safe every day.
That's fascinating. And what really gets me is how these systems affect every single person who's ever flown on an Airbus A320 or A321, even if they had no idea it was happening.
Well, it's like having multiple safety nets, each designed to catch you if the one above fails. The engineers call these reconfiguration control laws. Think of it like your smartphone's battery saving mode, but with much higher stakes.
Hmm, so how exactly does the system know when to switch between these different modes?
So here's where it gets really interesting. The plane constantly monitors thousands of parameters through multiple computers. When something goes wrong, it transitions through three main levels. Normal law, which is everything working perfectly, then alternate law, where some protections are reduced, and finally direct law, where it's mostly just the pilot and basic controls.
You know what's really clever about that? The way they've designed it to fail gracefully rather than all at once.
Exactly right. And check this out. In normal law, the plane physically prevents you from doing anything dangerous, like stalling or banking too steeply. But if systems start failing, it gradually removes these protections while giving pilots clear warnings about what's happening.
Well, that must require some pretty sophisticated communication between the plane and the pilots. Oh man, you should see how they've designed the display system. It uses these elegant green symbols that turn into amber crosses when protections are lost. And get this, if the plane enters what they call an abnormal attitude, like if the bank angle goes above 125 degrees, it actually gives pilots more direct control.
That's exactly what you'd want in an emergency. The system knowing when to step back and let pilot expertise take over. And here's something that really blows my mind. They've mapped out every possible combination of failures. Like if you lose both flight control computers or have a combination of hydraulic and electronic failures, the system knows exactly which capabilities to maintain and which to sacrifice.
So it sounds like they've essentially created a system that thinks like a pilot.
Well, more like a system that thinks with the pilot. Even in direct law, when most computerized protections are gone, it still provides crucial information. Speed warnings, stall alerts, bank angle warnings. It's like having a really knowledgeable co-pilot who knows exactly when to speak up.
That must have taken years of real-world experience to develop something so comprehensive.
Oh, you better believe it. Every incident, every close call, every pilot report has contributed to making this system what it is today. And here's the kicker. They even included what they call a mechanical backup mode, where pilots can still control the plane using direct mechanical connections if everything else fails.
That's remarkable engineering, building in so many layers of redundancy while keeping it all invisible to passengers.
And you know what really drives this home? These systems handle millions of flights every year, dealing with everything from minor sensor glitches to major system failures, and most passengers never even know it's happening. That's the true marvel of modern aviation.
Well, it certainly gives me a new appreciation for all the technology working behind the scenes on every flight.
And looking toward the future, these systems are only getting more sophisticated. The next generation of aircraft will likely have even more advanced protection systems, possibly incorporating artificial intelligence to predict potential failures before they even happen.